Hello everybody, Crazy Logics here. It's Damon, Crazy Logics 007 on YouTube. Still working on this JL Audio 1800 or A1800. Got the components out, desoldered everything, cleaned it up cleaned the pads up pretty good. Went through and did it with alcohol, and then went through with some acetone, got everything looking much better. You'll get a chance to see a close-up. Had all those FETs that were kind of left that didn't fall apart. Tested them all with the multimeter, and they were all dead short except for this one. So out of 16 FETs, one didn't test dead short. So we're going to go ahead and run it on our little tester here, and you're going to see it comes up as a double resistor. Let's see if we can get that in the camera just a little better there. And so that one's no good, but I wanted to show you what the little tester would come up when you get a FET that's no good, and that way you could see it. Let's get that out of the way and chuck that in the trash. So what we're going to do today is I want to bring my little camera over and I want to explain how to tell what banks are parallel. So these are where the driver transistors were, and we're going to be putting those back in. I have tested these resistors in circuit, and I've tested all these little surface mount resistors, and they're okay. Those survived. The capacitors, the gate FETs, the FETs, the drive transistors all died, and actually I think the main chip has died too. But you'll see coming from the transistors, the drive transistors, that they run up via a trace and go to where the resistors go in, and they actually go up here and goes to this nut and this nub and this one. And so then the resistor would be in here, and then you can see, hopefully, and if you look at your own boards, that there's a trace going up to here. So these transistors drive through the resistor to drive the FET. Now, you're looking for parallel banks, and since this is all connected to these spots, you can put your multimeter on diode check and get a beep from here to there, to there, to there, but it won't beep from this to that one because it's on a different part of the circuit. So we know that all four of these are in parallel, and so that is important. And we'll do that here. Let's get the meter out. We got it on continuity. We're going to go from that point. We know that one's in parallel, that one's in parallel, that one's in parallel. But look, when we go over here to this next bank, no beep. But all these are in parallel to each other. So we know we've got a bank of 4, and a bank of 4, bank of 4, and a bank of 4. And that's important to know because if we ignore that this has got 2 power supplies, for initial testing, once you get your drive circuit back in here and drive resistors in, you'll only need to put 1 FET per bank on the power supply side to test, because we're not going to test it up to full power or anything. We're just looking for the square waves. We're just looking for producing correct voltage. We're not going to be putting any load on it, so we can test that. Now, the other thing you do while you're down here and you've got everything cleaned off and stuff is make sure you got on continuity and you go from leg to leg. Now, there was a beep, but now it's okay. It's actually charging these capacitors. As long as that beep goes away, you kind of hear it go away. But we want to look for a permanent, long-standing beep. And what we're checking for is solder bridges. Now, I've cleaned the top and bottom of this board up, and I've already checked for solder bridges. And you can see the bottom looks pretty nice. We've got a little residue from the alcohol, but it's all nice and cleaned up. So that's important. Now, a couple other things while we got this open is I want to talk about these transformers. So when you see a power supply transformer, which we actually have 2 in this one for this side, one for that side, you need to go through and count the legs that are down into the board. This one has 8. There's 1, 2, 3, 4, 5, 6, 7, 8, and this one has 8. And why is that important? If the transformer has only 8 legs, that means it's got 2 series windings connected on the input side and 2 series windings connected on the output side, because 2 of these legs will be together for these to operate. If you don't find any other connections, that means that this amplifier is not making its other voltages from a separate set of windings. So there's 3 ways, or actually 2 ways, 3 ways, sorry, 3 ways you can make your other voltages. And your other voltages are for these chips over here, the op amps that are on the input side. They require a plus or minus like 15 volts, these, to be able to operate. And they're doing all the audio processing and stuff, your bass boosts, your gains, your crossovers, all that good stuff, and getting it into the drive circuit for the output. So in this amp, we don't have any extra windings here to produce the other voltages needed by the rest of the components. What we actually have is, if you follow it over, JL's put a little bitty tiny transformer over here that they're doing, and going through a couple of probably these 2 diodes right here to produce the lower voltages, because these are going to be producing the main rail voltage for the outputs, to produce the lower voltages and to get the plus minus 15 that the op amps need and all these other chips need. You're going to have other regulators, like this is a 5-volt regulator. Some of the chips and stuff is going to need a 5-volt reference or stuff like that. Your main drive chip also produces a 5-volt reference. So in the last video, I said I was going to do a little probing of this chip. This chip does not seem to be happy. If we look, and I don't know, maybe, I hope it shows up my mouse. This is the chip over there, and it has good voltage in, and it has good ground. So the VN and the VC we have also, but I'm not getting anything. This is the output A and output B. That's what should be going to the drive transistors to drive the power supply FETs. So normally when that happens, one of 2 things. One, you have an inverting input and a non-inverting input. And the non-inverting input needs to be higher than the inverting input to turn on the chip. This is where all your, on this chip specifically, this is where all the this non-inverting input is going to be, where all the protection circuits come in, and will, if they put a voltage to here, they'll shut the power supply down, and that's what's supposed to happen. Now there's also a shutdown pin that can be driven high that needs to be low, that you can bring those shutdown circuits into also. And every pin, this is a 3525 layout. Every pin's going to have different ones. The most common, the 549 and the 594 and the 494, they actually have a pair of these that come out a different one, and we'll see those in a different video. But anyway, that chip is not doing what it's supposed to, so I think it's going to have to be replaced. However, since we're not getting voltage here, I'm curious that part of this drive circuit, there might be additional traces, and you know, there's tons of little traces coming back here to this drive chip and stuff, and jumping all over back and forth, flipping back and forth between the board. It might be looking to see if it's getting a drive signal from these transistors, or that there's something there. So I'm going to go ahead and put in the drive transistors, replace the capacitors and the drive resistors, so that it's ready for FETs, and then I'll probe this again. I'll do that off camera, because if it's dead, I'm going to go ahead and wait for a chip to come in, and then I will show you probing this one dead, remove this, figure out anything else that's wrong, replace it, get that all working. But let's one step at a time. So I had talked about, I know I'm jumping around a little bit here, but I talked about how the voltages are produced for these others. There's another way they do it. They can take the main rail voltage, and if it's a smaller amplifier and the main rail voltage isn't too awfully higher than the plus or minus 15, they'll just step it down and run it through a pair of regulators that look a lot like FETs. It'll be a 7815 and a 7915. And they'll just go ahead and make the voltages that way through voltage regulators. Or, if you can see here, I got a little Memphis. You notice this one has its 4 over here, and it has its 4 main ones over here, but it's got a bunch of little single loops that go down in here. And those little single loops are just enough to feed the voltage regulators, which are, let's see, those are the power, those are the diodes, these are the 2 volt, nope. I don't know. It's hard to see with the glare from the light right now. But these extra windings will produce the extra voltages that are required for the op-amp chips on the input circuitry. So that's the other way you can do it, is there'll be a few spare windings on the power supply. Now this big inductor is not a second power supply winding. This is actually a little Class D amp, and so this is part of the output filter, output inductor here. But like I said, you can have a few extra windings that they do separate, so that when you power up this side, it makes a smaller voltage over here, and you can make a plus and minus there. So that's something to look for. Sam at which is Bear Vids on YouTube just did a video on a Class D amp, and he had those small windings on, and one of them was broke, and that was causing his voltage regulators not to get voltage over to his his negative side, I believe it was. I can't remember. I'd have to watch the video again. But not get the power to the opt amp. So the amp appeared to be functioning, working, powered up just fine, but there's no outputs because the opt amps were getting powered up, so that they couldn't get the signal from the input processing here to the output driver stage. So that's an important little thing to learn, and if I come across amps that have issues there, we'll solve those. Otherwise, go watch his video. You know, he shows some of his troubleshooting, and it's a really good video. But what I'm going to do now is I have made myself a little drawing that shows my 2 ones here, and I've labeled where these certain transistors are going to go. And I will look at this and do it. Also should take lots of pictures with your phone to help you identify where components are and go, but I always make a little drawing and label it before I even pull the components out. And it doesn't have to be nothing fancy. I mean, this is just chicken scratches. I'll go back later if I need to and either make this nice and neat, put some notes out here to the side, and then snap a picture and save it actually in a file folder called the JL A1800. Reason being is that there's a couple other amps JL kind of used in this 800X1 power amp series. There's different board revisions if you read the board revision, but that way I can build up a database, a library of stuff, because when this amp's fixed and you know your buddy's got it back in his car, you know, you won't have it to reference again. So making notes and stuff really important. Taking some good pictures is important, and keeping that, you know, making your own little file folders and notes and stuff. But I'm not going to make this one take forever long. Like I said, I'll reference that and put the 4 new transistors of each style, the PNP and NPNs. We got the new capacitors that were melted, and they'll just slip in. And what I do is I bring them in, and then you just kind of splay the legs on. I'm just going to poke that, but on the drive resistors, you know, just bend your legs and get your drive resistor to fit in there. On these small components, it's pretty easy. The legs are skinny and thin, and so you can you know, just spread them out so they set nice and flat on the board. Now, the one last thing I want to show before I end this, and I need my stick. I always use a wood stick to kind of hold this up when I'm stuffing components in the board and getting it in. On these drive transistors, and this is I'll get my old man specs out here. This is the 222. So I'll look at my paper, and I need to put a 222 on here, in here. Now, It's really nice that they drew on the board the flat side the way that this goes. You need to make sure you make notes of that. The original ones were mounted all the way down like this. See if you can see, all the way down, you know, pretty much flush. I will probably try to make them just a tiny bit taller, for two reasons. One, if they're just a little bit taller, it's easier to get a probe in there and get measurements from your oscilloscope and all that other stuff. The other thing being is that these things don't dissipate a lot of heat because they're so small. And actually these big metal legs do a pretty good job of helping dissipate some of that heat. So the more of the leg that's left there, I've seen, and there are certain repairs you can do. Oh, I don't want to muck with that. I don't know which one I pulled that from. Let's stick with this one. I'll have to look at those. Where a amplifier's design gets one of these too hot, and actually part of the solution to fix it is instead of installing it all the way down flush, is to bring it up and going ahead and leave this little bit of extra legs so it gets up into the airflow, especially if there's a fan, or it uses the metal of these legs to help radiate out some of the heat. And sometimes that tiny little bit is all it takes to make one of these components just a little more happy and go from failing after 5 or 6 years to lasting forever. And so that's, you know, heat is the killer of all electronics. That's why they got big heat sinks. That's why you put the thermal compound, all that other stuff, fans. So heat's the big killer. But I'm going to go ahead and install these. I'm going to install them about halfway up, just to give me an easy room to put probes for testing and stuff. At the factory, obviously, they're not too concerned about that. They're just going to stick them all in, wave soldered or something like that, and they've got special test setups that they'll do, and it doesn't matter. They're not necessarily going through and doing point by point like you do when you troubleshoot and you try to repair in your garage here. So those are the things I wanted to cover. Like I said, I'm going to stuff all these in and solder them up. That's just plain soldering and snipping. If I get something that solders a little difficult, I will use extra flux on it. I will go back and clean it if I have to, you know, with a fiber pencil, whatever it takes, and make sure I get good solder joints everywhere and everything's good. And then I will check for solder bridges between these holes here. I don't want to get a solder bridge on the top side or the bottom side of the board. But just double check all that before I power it up. Then, like I said, off camera, I'll power it up and see if that sent anything to bring that that non-inverting input up and maybe turn this on. If that did, or if it changed anything. I've got notes on the state of this with all this out, what it was getting and what it wasn't. See if anything changes. If nothing changes, I'll trace it back. There is a couple other chips here. I think this one is the LM319, which normally has a bunch of these, the protection circuit running to it, and then it runs over there to that inverting input, so you can put multiple different protection things here. Then I may have to probe this a little more to see why it's not putting out, make sure it's not damaged or anything else. But got a funny feeling this will either work perfect or this is actually damaged, since it blew those transistors. Remember, a couple over here were actually melted off and rattling around loose inside this amplifier when I first opened it up. So we either got an issue over here or maybe a little something, because it probably did take a hit when that happened. There was so much current draw, so might have to replace that too. But I'm going to have to build up all this other stuff, and we'll continue on. Next little short video will be focusing on getting drive. Once we get drive, we'll put one FET in each one of these parallel banks, and then we can look at the drive waves and make sure we're producing power, and then we'll populate it. Now, I did not take time to measure the installed height of these FETs, but that's an important thing. I use a postcard or a note card, and I'll hold it on the edge here, and I'll make a mark where the top of the FET is. But I've got all these FETs and these two diodes to get the exact measurement, because they were all installed the same height. So as long as I don't take all these out, I can always reference this, make my mark. But if you're going to end up having to take everything out of an amp that's got them upright so that you get them centered up in their with their insulator and where the clips hold them correctly, you need to get you something that you can put flat against the board. I take a little measurement, and then I'll write in there like this one right here says it's for a kicker CX A1800.1 inputs, and so that way I've got a nice measurement and I can kind of set those all along through there. You can also use this once you get one or two set, you can use a straight edge to help you set the others. Put a little dot of solder on there and stuff. So that was the other important thing. I'm looking at my little list here. Tested for solder bridges, show parallel component banks. We looked at the diagram. Talked about how I install some of these and why I install these a little taller. Talked about the cleaning and the inductor winds and a couple other things there. And those are the things I wanted to point out just as a little bit of education. And let's, like I said, go ahead and populate this sucker and see you in the next video, and we'll see if we can't get some drive waves out of this sucker. Thanks for watching the video. Comment, do a lot of comment, subscribe, like whatever, all the stuff that you hear everybody on YouTube say. The comments are fun. That's probably been the most fun of all this. It makes and prepare take forever doing video recording, but when you get comments back and stuff and people ask questions or somebody says, oh, that was cool or something, that's what makes it really fun. And then the subscriptions obviously help kind of grow your channel. People come in and they look at it, and if a lot of people subscribe, they think, well, maybe this guy might know what he's talking about. I don't fool yourself, but I enjoy doing this. It's a fun hobby. I focused originally on power supplies, and it went into amplifiers because there's lots of these around that are dead, and it's really important to learn about a switching power supply. We'll go over that in some other videos. I got some power supplies maybe we'll do. I know that's really boring to a lot of people. Car audio is more exciting, better for videos, but doing power supplies is definitely a thing, because everything, your laptop, your TV, all of them have a switching power supply, and that's what this is in it, and that's what provides power. So if it dies, that's one thing. If you start learning anything about electronics, is learning how the switching power supply works can help you fix more things electronic throughout your house and stuff. So it's kind of important. All right, hope you learned something. Like I said, I will see you in the next video. Thanks a bunch for watching this, and good luck with your stuff. I do have a small little amp that's going to make a perfect starter video that I'm going to try to get up here for a little more in-depth stuff on how to get started and all this. So, all right, thanks a bunch, and I'll see you next time. Okay, so while working on this amp, it's come to my attention that this chip has got to be bad. I have put some FETs in. I've rebuilt the circuit here and put FETs to test, and that didn't power this up. Probing and tracing and everything, I'm not getting the reference voltage out. I think this chip is bad. So what I want to do in this quick little blurb, whether this is individual or not, is show you how I remove surface mount chips. So what I do is I get my little soldering iron with a small tip on it, and I get some leaded solder, and I run it across the pins and mix some leaded solder in with the lead-free solder. Just get it in there real good, and that way it's nice and mixed in. And then I've got my hot air rework station. I've got it set to 380 degrees Celsius. I think I can change it to Fahrenheit, but I never have. I just know that 380 works. And then I'm going to gently heat the whole area, because I don't want to popcorn the board by doing it too much. Since this chip is going away, once I've got the area heated up a bit, I'll focus on the chip pretty hard, the chip itself, and let the heat dissipate down from it. I'll start to get it a little warm here. It's nice and going around here. Like I said, we don't want the board to popcorn. getting there. You'll see the solder start to melt, and then blammo, it'll just come off just like that. That's the other beauty of having that leaded solder on there, is it's a lot easier for me anyway to tell that it's melted. So now we're going to go in and take some of our desolder braid and clean all this up. Nippers. So one other thing we're going to do is, while we've got this chip out, we're going to take a picture of the underside of the chip so that we can see where these traces are going. I just carefully wiped all that. Getting a little drop of acetone. Clean up any of the flux and everything. Make this look all nice and pretty. And inspect it really well. What I'm inspecting it for is any little solder bridges, places solder should not be. There's a little solder nub. All right. So I've got some new chips here. I'll show you how I install them. There's a secret to this: you have to have the right stuff, but man, it has made it easy for me to put these surface mount chips on. Now, these drive chips are moisture sensitive when you go to put them in. Because they are assuming you're going to be using hot air rework to put them in, and if they accumulate too much moisture on the inside, the temperature will end up making the moisture inside bubble, boil, or whatever, steam, vent, something like that, and screw up the chip. But the way I do it, you don't have to do that. So we're going to get the chip out. Set it over here for a minute. Oh, there's a little bug. Had a couple little bugs. Of course, I'm out in my garage, so it doesn't surprise me. It's not like it's sealed tight. So I'll put all that back in there with the desiccant. I'll seal that up in my earliest convenience. So I take my soldering iron and a little bit of solder. Gotta get my glasses here. And pick the easiest to get, one of the easiest to get to pads. And we're just gonna put a little dab of solder there. And then we're gonna put the chip and we're gonna hold it in place with our tweezers. I know this is not gonna be the easiest to see, but I'm just going to solder that one pin down perfectly and hold it in place. And that should get it good. And I can come over here. That one pin will give you a little bit of flexibility. And I'll catch this other one. So when that cools off, that should not move. And here's my secret. Flux. I'm using Amtex flux. I'll put a little bit all the way across one side. Just a tiny, tiny bit. You don't need a ton. You just want to work some flux across all the pins. Enough flux down in there. Doesn't take much. I'm going to start with a clean soldering tip. Cleaned it off in my cleaner. I'm going to get some solder on one side here. And we're just going to rub across there where that flux is. That flux is going to do the job for us. It's going to make sure that that solder flows only where it needs to go. I just go real slow, and man, you'll just see it just. I mean, it's unbelievable. Get a little bit extra solder on there still. It won't make a bridge. The flux helps pull it to the places that it needs to go. It adds some surface tension, some wicking action, and bammo. And you know what I forgot to do? Take a picture. But I get to cheat because I have a camera, and so I can go into the editing and zoom in on there and see those pins. But I should have snapped a picture, just because you don't always get a chance to see all those traces, and you kind of sometimes have to guess and figure them out by trial and error, stuff like that. I'm just going to get a little acetone down in here. Clean all that flux up. You also need to pay attention. I already knew, but see if I can show you here on the old chip. Yeah, you can kind of see it right there. There's a little notch in the end of the chip, and that notch went this way. And so you got to use that because that tells you what pin's pin 1 and stuff when you look at the stuff. So now we got that in there. I'll make sure the chip's not all hot. Make sure the flux got out of the way, and I'm going to try powering this thing up. Oh my gosh, I've got square wave. That is beautiful. Let's see if I can adjust my camera here to get the scope in. Bam. That's a goofy looking square wave, but it's because JL normally likes to regulate stuff, and so we're not getting full duty cycle. So holy crap, the power supply is working. All we had to do is change that chip after rebuilding the whole thing. So now I'm going to take these off, kill the power here. Now I'm going to take these out and actually install the correct FETs. And when you come back, through the magic of YouTube or whatever, I'll have all these in. I may just join these videos together. So like I said, I tried all the put the circuit all together, and that didn't get it running. I even put in test FETs, that didn't get running. Now we've changed this chip, that was it. The on light was good, no protection come on. So now I'll put the correct FETs in, and then we can check voltages and stuff. All right, I will jump to that, and away we go. Sorry, should be bigger because I've got on times 10. There we go. There's the drive wave. Real nice and pretty. Now you can play with them out of the heatsink if everything's working at really low volume for a very, very, very short amount of time, because with no heat sink for them to dump their heat into, these transistors are going to overheat really, really quick. So you can do it just enough to make sure you're getting audio and get stopped, and then you really need to, if you're going to have to troubleshoot some stuff that isn't perfect, you know, get it back in the heat, cleaned up back in the heat sink, and then start looking at stuff while you test with audio and putting audio through it, you know, looking for distortion, stuff like that. But you can, let's see if I can add a little. And you, like I said, you would do this at extremely low volume. And only for a minute. And that's all we did. Only for a second, not a minute. And remember, always one finger touch. Never jump across FETs. You never know what kind of voltages are on the back of them. And don't be grounded with your other hand. You know, be not. So we've tested everything. Nothing got hot. The amp plays bass, man. It's going back in the heatsink. So, you know, going through and rebuilding the drive circuit, cleaning. You know, you noticed how dirty and terrible it looked before, and that was all just cleaning. It was because these FETs blew up, and so cleaning that all up. Since it did take out the drive transistors, it did go all the way back and knock this chip out, so we did have to replace that chip. Hopefully that little bit is showing you how I like to do the chips, and then by using quality flux you can just flow that across there and not have to hot air rework that. If you knew the chip was bad, where I use my hot air to take it out, if you have tiny little nips, you could technically nip these legs out to take the chip out, and then use your soldering iron to take each little leg off. Otherwise, it's if you don't have hot air, it's sucking as much of the solder off with a solder braid, and you know, using a little pick probe to lift as you're kind of doing, and get each leg to pop up with your soldering iron. It can be kind of tedious. And hot air rework stations have really came down in price. You can buy a cheapo economy one like mine, I think for $65, maybe a little more. And it does a good enough job, especially because I don't use it super tons. You know, this is a hobby, so I'm not like doing production work with it or making a living with it, so it does definitely good enough for me. So this will end up, I will have to do some video editing. I noticed in the first video there was a squeal when I took one of the clips off there. It caused my microphone to go crazy for 45, between 45 and 23, 445 and 523. No, oh, I've got the overhead light on. That's causing a lot of glare. That I've got to take out of the video, and I may just have to mute that section, and I'll put it in the notes. But it squeals loud through the speakers. Everybody would scream at me and hate me. You'd rather me delete the audio in that little section. So I'll try to get this all put together. I'm going to work actually on video editing on this one, and that'll help me out on some of my old videos I've already got done that I did with my phone. But I'll get the video edited. I'll probably chunk this into 2 videos, part 1 and part 2, so you don't have to keep pausing and do all that. You can eat it in a little more bite-sized chunks, and get this sucker back in the case. I'll put a thermal compound on it, get it on there, and then I will actually hook the real power up to it, and we will do some endurance testing. Make sure it sounds sweet, and then I'll put it on the big 1000-watt load and give it a good baking. Make sure nothing else is going to fry, because you know these may have endured some stuff. They got a little bit of discolor to them. Sometimes that's a discoloration from heat. Sometimes that's just how they were manufactured back at that date, and they don't have this sandblasted look like the new ones. So I really want to load test this and before it goes back out, because I'd hate for it to get stuck back in the car and pop 2 days later because these were weak. So anyway, hope you enjoyed this. You know, give me a subscribe if you don't mind. I appreciate that, and throw some comments down. I've got several more amps coming up, and like I said, thanks for watching, and hope you learned something. And repair, repair, repair. Don't throw stuff away. It's cheaper to fix it than it is to buy new. I don't know, this amp would be several $100s, and we've got, you know, 50 some odd, 60 some odd dollars in parts. You know, my time's basically free because I do it as a hobby. But you know, that's all. You can't buy a junk amp at Walmart for what we got in parts. So, you know, learning to do it and taking an interest in fixing things in your life can save you a bunch of money and provide you with some great satisfaction. So, anyway, like I said, thanks for watching. Catch you next time. Well, if you stuck around to the end of the video, you might have a question that says, man, that was great. Showed how to repair all this stuff, but you didn't show us how to put these clips back in, because they can be a royal pain. But there is a nifty little easy way I do it. First of all, I took a chunk of plastic that was a cut off that they were throwing away, and I cut me a bevel on it and left a flat, and then cut a little groove in the end of it. And that is so that it'll groove and pivot on this end. The other tool is my whole rubber mallet that my dog chewed on and stuff, and my kids have goofed with so much I'm missing one of the heads. But you just need a little rubber head, and it does not need to be heavy. You're going to take your clip, you're going to put it in the slot that's in here for these clips, and center it up over the fets, and put your little driver bar here. Now, the first time I do it, I have it leaned down more to drive it back more. I just give it a tap, and then the second time I lean it up more to drive it down a little. And so what that's doing is that is getting this clip piece in first for certain, and then driving it down just a little bit to make sure it's fully seated into that groove. And they just go really quick once you've kind of done it a couple times. Just put that on the center. Make sure, like I said, it's centered on the clip there. And it don't take much force or pressure, because just a little tap gets that clip over the edge. The single wide of this style clip you can normally do with just your thumb. There's a bigger, wider version of these that go over bigger style fets or go over more fets at once. That's really stiff. But you can inspect and make sure when you're done that they're all seated nice down in there, because you don't want them coming out. That would be bad. It would overheat it. So also, if the JL Audios, if you've watched the first video, which I know it's up, and if you're watching this video, you know I did it again, but I finally got my video editing program to work for me somewhat. Learned a lot, been doing some studying on it. That first video there, when I removed one of these clips, the high-pitched ping from it caused one of my microphones to have a ring from 4:45 into the video to 5:23. So a little over 30 seconds, almost 45 seconds worth of this high-pitched ring, which would have killed anybody listening to it. It was terrible. It was on the left channel only, and I was able to go in and edit the audio of that, mute that left channel, and make it to where you could still hear me, but it wasn't going to cause you pain and suffering. And that all exported and worked, and so I got that posted. It's not perfect video editing or anything, but the second video that will go up of this will have a whole bunch of these, a whole bunch of the stuff all edited together and maybe done a little bit better. But like I said, if you're seeing this one, that'll be my second successful edit and getting it to export correctly and not screw up on me, and where it'll upload. And so woohoo, I've got a bunch of other amps that I previously recorded with my cell phone that I hopefully can now edit and start posting a little bit more regular instead of having gaps of several days. I'm hoping to post every other day, maybe for a little while anyway, as I get through some of these. And so that's how you put the clips in. And I'll get the last of these in and get this thing going. And like I said, if you stayed to the end of the video, bonus material. So thanks again. Bye.